go! Today, you'll learn how to make a battle car with a controller. This is a really cool project that you can use for competitions, have fun with your dad or son, or show at the science fair at school. And what's special about it is that it's great for those who are just starting to work with electrical circuits, installing their first switches, small motors, wire connections, and all that. And no, there's no Arduino or any complicated electronics involved. This small car is part of a series of 8 videos we're making to launch the Manual Maker website, a place for you to share the projects you've invented, but also to get inspired by projects that other people have shared. So let's go. Today I'm going to do the opposite of what we've been doing in the previous videos, okay? Today, rather than creating and posting a new tutorial, I'm using one that's already on the site. Our team tested, prepared, and published it on Manual Maker, but I didn't create it. So I'm going to follow the step-by-step instructions from the site, and let's see how it turns out. 2 motors with reduction, and tires with wheels, a tactile switch, a slide switch, 5 meters of black flexible wire, 5 meters of red flexible wire, 30 centimeters of yellow wire, a battery holder, 4 batteries, a sheet of cardboard, 2 safety pins, a barbecue stick, a party balloon, masking tape, and a clothespin, tools hot glue gun, flush cutter pliers, wire stripper pliers, hand drill, and quick release clamp are optional. Haute solder, specific tools, soldering iron with soldering iron stand, and safety glasses. I can use cardboard or medium density fiberboard for the car body. There's a laser cutting file or a hand cut template available. I'm feeling lazy today because I want to see this car in action soon. Let's use the laser to cut it. But this is also very simple. You could easily do it by hand too, okay? You can just use a utility knife and a ruler, that's it. To assemble it, match and join the numbered sides of the pieces. You can keep the numbers facing inward on the car to hide them. Well, I cut too deep and the number ended up outside, but that's okay. Use hot glue to join the pieces. The back of the car is open, which will give you access to the inside for any maintenance. After cutting the controller, insert the buttons. Glue the slide switches. With hot glue, secure other buttons with a nut. Glue the battery holder between the slide switches. Time to solder behind the buttons. Also, it's more helpful if you use the website and look at the pictures than me explaining it in a video. Click, there's a numbering behind the button, and you have to connect one number to the other when we're soldering. It's a good idea to wear glasses, okay? Solder could fly into your eye, which isn't good. There are 6 terminals here. Basically, I have to solder in an X shape, connecting the top ends to the bottom ends. I need to solder the battery holder wires, but one is too short. Let's splice it. Lucky for you, there's the website, so I won't be bothering anyone talking about a wire that goes from terminal A to B, then to 1, 2, the red and the black, ending at the tip of something, I don't know what it is. It's all there on manualmaker.com, okay? And now comes an important part, which is the cables that connect to the car, right? This controller will be relatively far from the car. According to the tutorial here, I need 2 pairs of 2 meters each. 2 pairs of 2 meters, that's 8, right? Let's use this measuring tape.
I think you should measure on the...
What? Measure by hand like this? But how am I supposed to know? A meter from where?
From one shoulder to the
From
tip.
the shoulder to the tip of the fingers, 1 meter. Let's see if Danny is right or wrong. From the tip of our fingers to the shoulder.
Yeah.
Just for the record, there was a difference of about 10 centimeters at the end. Danny, this body measurement here is from the time of the English, the yard and inch. We've been using the metric system for a few years now, and now here this website is telling me that I should fasten these ends somewhere. In this case, you're supposed to use something like this clamp and then wind it up with a drill so it stays neat and doesn't end up a tangled mess of wires. Do you think it'll work? I've never done this before, you know. It really helps a lot, doesn't it? Let's solder this to the controller. Once again, I'm gonna follow the instructions from the website for soldering, and in the end I'll secure it with masking tape so I don't put too much strain on the solder joints I just made. After I test it, I can secure these wires here with hot glue. I don't want to risk it now, since removing masking tape is much easier than removing hot glue if I make a mistake. I already fixed the other end here, since Danny taught me how to measure it wrong. I'll solder it to the motors, okay? I need to solder it mirrored as they're explaining. So if the red wire goes on one side of one motor, the other motor will have the black wire. What's red on one side will be black on the other. It's easier for you to see once it's done. The way I'm explaining it sounds really difficult, but it's actually extremely easy. Now see what I said? The black wire here is on the left, on the other motor it's on the right. The red wire is on the right, and here the red wire is on the left. And finally, we can test our controller because the electrical part is 100% ready. So theoretically, the moment I press the button, these little guys are spinning. We gotta test reverse too and see if they're spinning the other way. Everything worked, so I can now hot glue it to the back of the controller. I'm also gonna add reinforcement behind this controller, though it's not in the project. I'll glue a popsicle stick back here to make it sturdier, since the cardboard seems flimsy. Now, here's something that kind of messes with our heads. If I press the right button, a motor will turn on here, and then I can put this motor on the right side of the car, right? That won't be very good. Look at the logic of it. My hands are like the two wheels. Ita. If I turn on only the right wheel, so it can turn to the right, actually it'll activate and turn the car to the left. If I turn on the left wheel, it spins and pushes the car to the right, so I need to do the opposite. When I press the right button, it's the left wheel that spins. And since the motor has two shafts, it's hard for me to know which side of the shaft goes here. So, in practice, you put the motor in the car, attach the wheel, and then you test it to see if it's working the way it should. It's spinning correctly and shifting into reverse. Yep, that's good. I can already install the other one, and it's good to also test it. Look, it's working properly now. I can finally glue it. I want the cable to come out from the top, so I'm gonna run the control through here and make a small cut here, a cut in the corner of this cover. We're missing the front wheels, and that's why we have a barbecue stick. Oh yeah, man. Now that we've seen it's working, I'm also gonna secure it with tape and then use some hot glue, because otherwise we'll keep putting stress on the motor solder joints all the time. Two tasks remain. First, glue the clothespin inside the car. It'll be the one holding the balloon, which will be the target for the other car. The second thing is to install the weapon. I'll hot glue these safety pins to the front of the car and use a support to keep them from falling while the glue sets. And I think our little guy is ready. How is this going to work? Fill a balloon and attach it to the clothespin inside the car. The goal of each competitor is to pop the other person's balloon using these pins here at the tip.
Before we have a match, let's give this robot a mean face, right?
The front opening is for maintenance, but I could put a piece of paper here for decoration. If we need to work on it, we can take it off. Let's test this little guy on the floor. Come here and see how this controller works. I push both levers forward, press both buttons, and it goes forward. If I push both levers back and press the buttons, it goes backward. If I push both levers forward and press only one button, it should turn. The wheel isn't touching the ground, it's missing some weight. Let's put a piece of something heavy inside to add some weight. Now that's better. Total control. Look at this. Shall we battle? We already had a second car, which was made for testing, and it's a bit tamer than this one, as you can see.
But how's it gonna work?
Best out of three.
But is there any strategy?
There are no rules, but you just can't use the string to get in the other person's way. All right? Let's go. 1, 2, 3, go! Oops. One thing I noticed, your weapon has a disadvantage.
I think I already figured it out.
Which one?
These are close to each other, but yours is wider.
Exactly. These needles are far apart, right?
Yes.
And then I end up with a bigger weapon, right? It's easier to hit. No, no, no. The balance fell and it hit on my own weapon.
1, 2, 3, and go!
Oh, no.
It is 9 deep. No!
One of my wheels isn't touching the ground. I can't turn right, I can't control the car without one wheel getting traction. You lost both front ones. Let's try to change that. We'll replace the front wheels with a little ball, half a ping pong ball. Better look. Not to brag, but these guys are fired up now. It's gonna be a whole other level.
Oh man. Wait, what did I do?
Yeah. No, but it turned out really good. Now it looks awesome. Look, 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 the donut.